Jai Hind, welcome to our another video of mathematics series. In this video, we will discuss about the important formulas of trigonometry. We will also see how some important formulas of trigonometry are derived. So let's begin without wasting any time. First of all, let us know what is trigonometry. So trigonometry is basically the study of ratio of various sides of a triangle attached with each other at different angles.
Hand on the wheel, got my pistons pumping, all 800 horses running. Oh baby.
Now let's talk about measurement of angles. The measurement of angle is the amount of rotation from the initial side to the terminal side. The sense of an angle is positive or negative according as the initial side rotates an anti-clockwise or clockwise direction to get the terminal side. There are three systems for measuring angles. These are sexagemal system, centesimal system, circular system. In sexagemal system, one right angle equals to 90 degrees, 1 degree equals to 60 minutes and 1 minute equals to 60 seconds. Whereas in centesimal system, one right angle equals to 100 grades, 1 grade equals to 100 minutes and 1 minute equals to 100 seconds. And in circular system, the unit of measurement is radian. 1 radian is the measure of an angle subtended at center of a circle by an arc to the radius of the circle. Pi radians equal to 180 degree.
Born to ride, Mustang 65, got that V8 engine with a fuel injection. Drop the clutch, pedal to the floor, turn that giddy button to a lion's roar. Dream machine, racing queen, I'll take you.
Now let's talk about trigonometric functions. First of all, let's look at a right angle triangle. So in a right angle triangle, there are three sides. Two of these three sides are attached with each other at a right angle. This side is known as the hypotenuse. The side at the bottom is known as the base. The side attached to the base at 90 degrees is called the perpendicular. P denotes perpendicular, H denotes hypotenuse and B denotes base. So there are 6 trigonometric ratios. These are namely sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. We name this angle as theta. Now let's see what these trigonometric ratios denote. So first of all, sin theta. Sin theta denotes the ratio of perpendicular by hypotenuse. Cos theta denotes the ratio of base by hypotenuse. And tan theta denotes the ratio of perpendicular by base. Cosec theta denotes the ratio of hypotenuse by perpendicular. Sec theta denotes the ratio of hypotenuse by base. Whereas cot theta denotes the ratio of base by perpendicular. So these were the 6 fundamental trigonometric ratios which signifies the ratio of different sides of a triangle. Now we will try to relate these 6 fundamental trigonometric ratios with each other. As said earlier, sin theta equals to perpendicular by hypotenuse, cos theta equals to base by hypotenuse and tan theta equals to perpendicular by base, whereas cosec theta equals to hypotenuse by base, sec theta equals to hypotenuse by base and cot theta equals to base by perpendicular. So as we can see, sin theta equals to perpendicular by hypotenuse and cosec theta equals to hypotenuse by perpendicular. So we can see that cosec theta is actually the reciprocal of the sin theta. So we can write that sin theta equals to 1 by cosec theta or cosec theta equals to 1 by sin theta. Similarly, we can see that cos theta equals to base by hypotenuse, whereas sec theta equals to hypotenuse by base. So we can see that sec theta is actually the reciprocal of cos theta. So we can write that cos theta equals to 1 by sec theta, or sec theta equals to 1 by cos theta. Now in case of tan theta, we can see that tan theta equals to perpendicular by base and cot theta equals to base by perpendicular. So cot theta is actually the reciprocal of tan theta. So we can write tan theta equals to 1 by cot theta, or cot theta equals to 1 by tan theta. So this was it. Now we will try to relate these trigonometric functions in another way. Let's see. Now let's look at some fundamental relations between these trigonometric ratios. Cos of 90 degree minus theta equals to sin theta, and sin of 90 degree minus theta equals to cos theta. Similarly, tan of 90 degree minus theta equals to cot theta, and cot of 90 degree minus theta equals to tan theta. Sec of 90 degree minus theta equals to cosec theta, and cosec of 90 degree minus theta equals to sec theta. So these were some fundamental relations between the trigonometric ratios. These are to be remembered. Now we will see what will be the values of trigonometric ratios if we add their squares. So let's see. Sin square theta plus cos square theta equals to 1, or cos square theta equals to 1 minus sin square theta, and sin square theta equals to 1 minus cos square theta. Similarly, sec square theta minus tan square theta equals to 1, and 1 plus tan square theta equals to sec square theta, and sec square theta minus 1 equals to tan square theta. Lastly, 1 plus cot square theta equals to cosec square theta. Cosec square theta minus cot square theta equals to 1, and cosec square theta minus 1 equals to cot square theta. So these were all the fundamental relations between the 6 trigonometric ratios. Now let's talk about the values of trigonometric ratios at negative angles or positive angles. So let's see. So sine of minus x or minus theta equals to minus sine x, or cosec of minus x equal to minus cosec x. This happens because cosec x is the reciprocal of sine x, so the value of angle remains the same. Next we will talk about the value of cos of minus x. So cos of minus x equal to cos x, or sec of minus x will be equal to sec x. The reason is same, because sec x is the reciprocal of cos x. Now tan of minus x equals to minus tan x, or cot of minus x equal to minus cot x. These were some fundamental values of trigonometric ratios at their negative angles. Now let's talk about the value of trigonometric ratios at different quadrants of a 2D space. This is called the first quadrant, this is the second quadrant, this is the third quadrant, and lastly this is the fourth quadrant. So there are 4 quadrants in a 2D graph. In the first quadrant, the value of all the trigonometric ratios are positive. In the second quadrant, the value of sine theta and cosec theta are positive, and the value of tan theta, cos theta, sec theta and cot theta are negative in this quadrant. In third quadrant, the value of tan theta and cot theta are positive, and rest other trigonometric ratios are negative in this quadrant. In fourth quadrant, the value of cos theta and sec theta are positive and rest other trigonometric ratios in this quadrant are negative. Now we will see the trigonometric ratios at some uncommon angles. So let's see. So first of all, the value of sine of pi by 2 plus x or 90 degree plus x. So the value of pi by 2 plus x. Pi by 2 lies here and x, let's say here. Pi by 2 plus x means the angle will be in second quadrant. So sine of pi by 2 plus x will be cos x, and the value as it was sine x, the angle was with sine x and the angle lies in the second quadrant. So the sine will be positive only as it is, and x is added with pi by 2 or 90 degree. So the ratio will be changed to cos and the value will be cos x. Next is value of cos of pi by 2 plus x. Similarly, pi by 2 lies here and pi by 2 plus x will lie in the second quadrant and the ratio is cos. So as I told that sine is only positive in the second quadrant, so cos will be negative here, and as the angle is added with pi by 2, so it will remain x but the ratio will change. So it will be minus of sine x. The value of cos of pi by 2 plus x is minus of sine x. Now our next value is tan of pi by 2 plus x. Again pi by 2 lies here and pi by 2 plus x will lie in the second quadrant, and as I have told, in the second quadrant only sine is positive and rest other ratios are negative. So the sine will be negative, and as the angle x is added with plus pi by 2, so the ratio will be changed from tan to cot. So the value will be cot of x. So the value of tan pi by 2 plus x is cot of x. Now let's see the value of sec of pi by 2 plus x. As said that sec x is the reciprocal of cos x. So the sign conventions and everything will be same as cos x. So the angle pi by 2 plus x will be, pi by 2 is here and plus x will lie in the second quadrant, and as it is sec x, so sec x is not positive in the second quadrant. Only sin x and cosec x are positive in the second quadrant. So our sign will be negative and the ratio sec x will be changed to cosec x and the value of angle will be x. So the value of sec of pi by 2 plus x is minus of cosec x. Now we will see what will be the value of cosec of pi by 2 plus x. So pi by 2 plus x will be, the pi by 2 lies here and plus x will lie in the second quadrant, and as told sin x and cosec x are positive in the second quadrant. So the sign will be as usual positive and cosec x ratio will be changed to sec. So it will be sec of x. So the value of cosec of pi by 2 plus x is sec of x. Next is our cot of pi by 2 plus x. So the angle pi by 2 lies here and plus x will lie in the second quadrant, and cot is negative in the second quadrant. So the sign will be changed to minus and the value of pi by 2 plus will be x and the ratio will be changed to tan. So the value of pi by 2 plus x will be minus of tan x. Next is our value of sine of pi minus x. So pi minus x. So angle pi will be 180 degree means here, and plus minus x. Minus x will be here somewhere, let's say minus x. In the third quadrant sine is negative, so it will be changed to minus, and pi minus x, so it will be sine of minus x. If the value of any angle is the outcome of difference with pi or sum with pi, then the ratio will not change. In case of pi by 2 it changes, but in case of pi it doesn't change. So it will be minus sine and the value will be minus x, and as told sine of minus of x is minus sine x. So minus of minus sine x will be sine x. So the value of sine of pi minus x is sine x. Next we will calculate the value of cos of pi minus x. So pi minus x, pi angle is here and minus x is somewhere in the third quadrant, and in third quadrant cos is negative, so we'll put the sign of minus, and as it is pi minus x, so the ratio will be same, cos and value of angle will be minus x, and as told cos of minus x is cos x, so minus cos of minus x will be minus cos x. So the value of cos pi minus x is minus cos x. Next we will calculate the value of tan of pi minus x. Angle pi is here and minus x is somewhere here. So value of tan is positive in the third quadrant, so the sign will be same, and as it is pi minus x, so the ratio will be also same, so it will be tan of minus x, and as told, tan of minus x is minus tan x, so the value of tan pi minus x is minus of tan x. Next we will calculate the value of cot of pi minus x. Pi is here and minus x will be somewhere in the third quadrant, and cot and tan is positive in the third quadrant, so sign will be same, and as it is pi plus of minus x, so it will be cot, the ratio doesn't changes, so cot of minus x, and cot of minus x is minus cot x, so the value of cot of pi minus x is minus cot x. Next we will calculate the value of cosec of pi minus x. So in case of cosec of pi minus x, the pi is somewhere here and minus x will be in the third quadrant, and in third quadrant cosec is negative, so the sign will be negative, and the ratio remains the same, cosec, and the value will be minus x. As I told, cosec of minus x is minus cosec x, so minus of minus cosec x will be cosec x, so the value of cosec of pi minus x is cosec x. Next will be sec of pi minus x. Pi is somewhere here and minus x will be in the third quadrant. In third quadrant sec is negative, so minus, and ratio will remain same, sec, and value will be changed to minus x. Minus sec of minus x is sec x, so it will be minus sec x, so the value of sec of pi minus x is minus sec x. Now we will calculate the value of sine of 3 pi by 2 minus x. So the value 3 pi is here and minus x is somewhere in the third quadrant where sine is negative, and as it is an odd multiple of pi by 2, so the ratio will be changed. The sign will be minus at first and the ratio will be changed to cos. So 3 pi by 2 minus x, the value will be minus x here, so cos of minus x is cos x and the minus here, so the value of sine of 3 pi by 2 minus x is minus cos x. Next we will calculate the value of cos of 3 pi by 2 minus x. 3 pi by 2 is here and minus x is somewhere in the fourth quadrant. In fourth quadrant cos is positive, sine will remain the same and the ratio will be changed to sine, so it will be sine of minus x. Sine of minus x is minus sine x, so the value of cos of 3 pi by 2 minus x is minus sine. Now let's calculate the value of tan 3 pi by 2 minus x. 3 pi by 2 is somewhere here and minus x will be in the fourth quadrant. In fourth quadrant tan is negative, so the sign will be minus and the ratio of tan will be changed to cot and the value will be minus x. Cot of minus x is minus cot x, so minus of minus cot x will be equals to cot x. So tan 3 pi by 2 minus x is cot x. Next we will calculate the value of cosec of 3 pi by 2 minus x. 3 pi by 2 is somewhere here and minus x will be in the fourth quadrant, so cosec is negative in fourth quadrant, so the sign will be minus and cosec will be changed to sec and the value of angle will be minus x. Sec of minus x is sec x, so minus sec x, so the value of cosec of 3 pi by 2 minus x will be minus sec x. Now let's calculate the value of sec of 3 pi by 2 minus x. 3 pi by 2 is somewhere here and the minus x is in the fourth quadrant. In fourth quadrant sec is positive, so the sign will remain same and the ratio of sec will be changed to cosec and the value of angle will be minus x, so cosec of minus x is minus cosec x, so the value of sec of 3 pi by 2 minus x is minus cosec x. Now we will calculate the value of cot of 3 pi by 2 minus x. 3 pi by 2 is here and minus x is somewhere in the fourth quadrant. The value of cot x in the fourth quadrant is negative, so the sign will be negative and the ratio will be changed to tan and the value of angle will be minus x and tan of minus x is minus tan x, so minus of minus tan x is tan x, so the value of cot of 3 pi by 2 minus x is tan x. Now we will calculate the value of sine of 3 pi by 2 plus x. In case of 3 pi by 2 plus x, 3 pi by 2 is somewhere here and x will be in this fourth quadrant, and in fourth quadrant sign is negative, the value of sign is negative, so the sign will be minus and the ratio sign will be changed to cos and the value will be x. So sign of 3 pi by 2 plus x is minus cos x. Next we will calculate the value of cos of 3 pi by 2 plus x. So 3 pi by 2 is somewhere here and plus x will be in the fourth quadrant. In fourth quadrant cos is positive, so the sign will be positive only and the ratio cos will be changed to sin and the value of angle will be x. So the value of cos of 3 pi by 2 plus x is sin x. Now the value of tan of 3 pi by 2 plus x. So 3 pi by 2 is here and x is in the fourth quadrant. In fourth quadrant tan is negative, so the sign will be negative and the ratio will be changed to cot, minus cot of x. So the value of 3 pi by 2 plus x is minus of cot x. Now let's calculate the value of sec of 3 pi by 2 plus x. 3 pi by 2 is here and x is in the fourth quadrant, so sec is positive in the fourth quadrant, so the sign will be positive as usual and the ratio sec will be changed to cosec and the value of angle will be x. So sec of 3 pi by 2 plus x is cosec x. Next is our cosec of 3 pi by 2 plus x. 3 pi by 2 is here and x is somewhere in the fourth quadrant. In fourth quadrant cosec is negative, so the sign will be negative, minus the ratio cosec will be changed to sec and the value of angle will be x. So the value of cosec of 3 pi by 2 plus x is minus sec x. Next is cot of 3 pi by 2 plus x. 3 pi by 2 is here and x is somewhere in the fourth quadrant. The value of cot in the fourth quadrant is negative, so it will be minus and the ratio will be changed to tan. The value of angle will be x. So the value of cot of 3 pi by 2 plus x is minus tan x. Next we will calculate the value of sine of 2 pi minus x. So in 2 pi lies here and minus x is somewhere in the first quadrant where all the ratios are positive. The sign will be positive only and the ratio sign will be as usual sign and the value of angle is minus x. So sine of minus x is minus sin x. So the value of 2 pi minus x is minus sin x. Next we will calculate the value of cos of 2 pi minus x. Again 2 pi is here and minus x is somewhere in the first quadrant where all the ratios are positive, so the value will be cos of minus x and cos of minus x is cos x, so the value of cos of 2 pi minus x is cos x. Next we will calculate the value of tan of 2 pi minus x. 2 pi is here and minus x is somewhere in the first quadrant where all the ratios are positive and the ratio tan will not change, so it will be tan of minus x and tan of minus x is minus tan x, so the value of tan of 2 pi minus x is minus tan x. Next value is our cosec of 2 pi minus x. 2 pi is here and minus x is somewhere in the first quadrant where all the ratios are positive and ratio cosec will not change, so it will be cosec and the value of angle will be minus x. Cosec of minus x is minus cosec x, so the value of cosec of 2 pi minus x is minus cosec x. Next we will calculate the value of sec of 2 pi minus x. So 2 pi is somewhere here and minus x will be in the first quadrant where all the ratios are positive, so the sign will be positive only and the ratio sec will be sec and the value of angle will be minus x. Sec of minus x is equal to sec x, so the value of sec of 2 pi minus x is sec x. And lastly we will calculate the value of cot of 2 pi minus x. 2 pi is here and minus x is somewhere in the first quadrant where all the ratios are positive, so the sign will be positive as usual and ratio will also not change, so it will be cot and the value of angle will be minus x. Cot of minus x is minus cot x, so the value of cot of 2 pi minus x is minus cot x. So these were the values of the trigonometric ratios at some common and uncommon angles. Now point to be noted that sine and cosine functions and their reciprocals, that is cosine and sine functions, are periodic functions with period 2 pi, and tangents and cotangents of function are periodic with period pi. Next point is cosine and sine functions are even functions and all other trigonometric functions are odd functions. So only cosine and sine functions are even functions and rest all other, that is sine, cos, tan, cosec, sec and cot, are odd functions. So these were all about the fundamentals of trigonometry. Now let's talk about the values of trigonometric ratios at some common angles. So first of all, the value of sine of 0 degree is 0. The value of sine of 30 degree is half. The value of sine of 45 degree is 1 by root 2. The value of sine of 60 degrees is root 3 by 2. The value of sine of 90 degrees is 1. The value of sine of 180 degree is 0. The value of sine of 270 degree is minus 1. And lastly, the value of sine of 360 degree is 0. Now, value of cos of 0 degree is 1. Value of cos of 30 degree is root 3 by 2. Value of cos of 45 degree is 1 by root 2. The value of cos of 60 degrees is 1 by 2. The value of cos of 90 degrees is 0. The value of cos of 180 degrees is minus 1. The value of cos of 270 degrees is 0. And lastly, the value of cos of 360 degrees is 1. Next, the value of tan 0 degree is 0. The value of tan of 30 degree is 1 by root 3. The value of tan of 45 degrees is 1. The value of tan of 60 degree is root 3. And the value of tan of 90 degrees is infinity or undefined. The value of tan of 180 degrees is 0. Again, value of tan of 270 degrees is undefined. The value of tan of 360 degrees is 0. Next, let's talk about the values of different angles at cosec theta. So the value of cosec of 0 degree is infinity or undefined. The value of cosec of 30 degree is 2. The value of cosec of 45 degrees is root 2. The value of cosec of 60 degree is 1 by root 3. The value of cosec of 90 degrees is 1. The value of cosec of 180 degrees is infinity or undefined. The value of cos of 270 degrees is minus 1. And value of cos of 360 degrees is undefined or infinity. Next, the value of sec of 0 degree is 1. The value of sec of 30 degree is 2 by root 3. The value of sec of 45 degrees is root 2. The value of sec of 60 degrees is 2. The value of sec of 90 degrees is infinity or undefined. The value of sec of 180 degrees is minus 1. The value of sec of 270 degrees is infinity or undefined. The value of sec of 360 degrees is 1. Next, the value of cot of 0 degree is infinity. The value of cot of 30 degree is root 3. The value of cot of 45 degrees is 1. The value of cot of 60 degree is 1 by root 3. The value of cot of 90 degree is 0. The value of cot of 180 degree is infinity or undefined. The value of cot of 270 degrees is 0. The value of cot of 360 degrees is 0. So these were the values of trigonometric ratios at some common angles.
Drop the clutch, pedal to the floor, turn that giddy part into a lion's roar.
Now we will talk about the graphs of the trigonometric ratios.
I'll take you wherever you wanna go. Let's go.
So firstly, the graph of sin x. So this is the graph of sin x. Now why the graph of sin x is like this? So first let us draw a graph, and our extremities will be 1 and minus 1 in the y and y dash respectively, and this will be x and this will be x dash. So we will take the values of 0, pi by 4, pi by 2, pi, 5 pi by 4, 3 pi by 2, and so on. And in the x dash quadrant, we will take minus pi by 4, minus pi by 2, minus 3 pi by 4, minus pi, and so on. Value of sine of 0 is 0. So we'll plot the point here. Now the value of sine of pi by 2 is 1. So the point will be here. So we'll join this point. Next, the value of pi is again 0. So our point will be here. So the graph will move down to here. Next, value of 3 pi by 2 is minus 1. So our point will be here. So it will move on like this, in this way. Again, the value of minus pi by 2 is minus 1. So our graph will move here. And value of minus pi is this one. So our graph looks like, as mentioned in the figure, it will be an wave like this. And it will, the extremities will be 1 and minus 1. The graph will be in a wave pattern in which the extremity will lie in the minus 1 to 1. Next, let's see the graph of cos x. So this is the graph of cos x. Let's see why the graph of cos x is like this. Again, the extremities of y and y dash will be 1 and minus 1 respectively. We'll take 0, pi by 4, pi by 2, 3 pi by 4, and again pi, and again 5 pi by 4, and again 3 pi by 2, and again 7 pi by 4, and so on. And in the negative side, we will take minus pi by 4, and then minus pi by 2, and then minus 3 pi by 4, and then minus pi, and then minus 5 pi by 4, and so on. So value of cos 0, here will be origin will be 0. So the value of cos 0 is 1 and value of cos pi by 2 is 0. So we'll point the plot here for value of cos 0 in the 1 and the value of cos pi by 2 will be here. So our points will be joined here. Next, the value of cos pi is minus 1. So our point will be plotted here. We'll join this, and the value of 3 pi by 2 is 0 again. So our point will be here, and it will be joined here. It will move like this in the same way. Now value of minus pi by 2 is 0 again, so it will move here. The value of minus pi is minus 1, so here it is our, let's say, minus pi. So the value of minus pi will be here. So the graph is like this. Now let's move on to the next graph, that is the graph of tan x. So here in the screen you can see the graph of tan x. So you'll see why the graph of tan x is like this. So the value of tan of 0 is 0 degree. The value of tan of pi by 4 is 1. So the first point will be here, and second point will be here, and the value of pi by 2, that is infinity. So our graph will move on like this, not touch the point anywhere. So our graph will be somewhere very close and parallel to this line. And again, the value of minus pi by 4 is minus 1 and minus pi by 2 is infinity. So graph will move on like this parallelly. Next is the value of 3 pi by 4. The value of pi by 2 is undefined. Simply draw a graph here also from this side, and then the value of 3 pi by 4 is minus 1. So the point will be somewhere here, and pi is 0. So the point will be somewhere here, and then value of 5 pi by 4 is 1 again. So the value will be somewhere here, and the value of, let's say, 7 pi by 4 is again undefined. So it will again go like this up infinity to infinity and in parallel way and not meet. So this was it, the graph of tan x. Now next graph is our graph of cosec x. So this graph is the graph of cosec x. So let's see why the graph of cosec x is like this. The value of cosec of 0 is infinity, so it will move on like this. The value of cosec of pi by 2 is 1, so the point will be somewhere here and it will meet here. Again, the value of cosec of pi is infinity, so it will again move parallel to this line somewhere here. Now the value of pi was undefined, so we'll draw a line here. It will simply go just like this and parallel to this. the value of 3 pi by 2 is -1 as said, so the point will be somewhere here, and again it will move on like this in the same fashion. Next point is our 3 pi by 2 in the 2 pi, so in 2 pi it will move on like this. And in this case also the value of cosec of 0 was infinity, so it will move on parallel to this, and in minus pi by 2 it is -1, so the point will be somewhere here. And again in cosec minus pi the value is again undefined, so it will move on like this. So the graph of cosec x is like this because of its values. Our next graph is the graph of sec x. So the graph of sec x is this. So let's see why it is like this. So the value of sec of 0 degree is 1. So our first point will be here, and the value of sec of pi by 2 is infinity. So it will move parallel to this line. It will move parallel to x equal to pi by 2 and never meet it. And again the value of cos of minus pi by 2 is again undefined, so it will move on like this, and here it will be same line. And the value of minus pi is -1. Again the point will be somewhere here, and the graph will be curved and meet here. And again the value of sec of -3 pi by 2 is again undefined, so it will go up like this. Next again the value of sec pi is -1, so the point will be somewhere here. And as the value of cosec of pi by 2 was infinity, so this will be somewhere go parallel to this line x equal to minus pi by 2, and it will again move on for cosec 3 pi by 2. It will again go parallel and like this. So the graph of sec x is like this. Our next graph is the graph of Cortex. So the graph of Cortex is somewhat similar to tan x but a bit different. So let's see why. This is the graph of Cortex. Let's see why it is like this. Cot of 0 degree is infinity, so a line will be like here and infinity, and it will go parallel to the y-axis. And the value of cot of pi by 2 is 0, so a point will be here and the graph will meet here. Again value of cot of pi is infinity or undefined, so the graph will simply take a turn and move parallel to x equal to pi. The value of cot of 0 was infinity, so we'll draw a line parallel to this y dash axis also. And the value of cot of pi by 2 was 0, so the graph will meet here. And again the value of cot of minus pi is infinity, so the graph will move on here and move parallel to x equal to, let's say, minus pi. So this is the graph of Cortex. So this was all about the graphs of different trigonometric ratios.
Drop the clutch, pedal to the floor, turn that kitty pot into a lion's roar. Dream machine, racing queen, I'll take you wherever you wanna go. Let's slow this down, break the speed of sound. Tonight we own the road.
Now you will learn about the values of trigonometric ratios at sum and difference of various angles. So let's see first the values of trigonometric ratios at sum of various angles. So first of all, sine of a plus b equals to sine of a into cos of b plus cos of a into sine of b. This is a fundamental formula. Next is value of sine of a minus b, which is sine of a into cos of b minus cos of a into sine of b. Next is our cos of a plus b, which is equals to cos of a into cos of b minus sine of a into sine of b. Next is the value of cos of a minus b, which is equals to cos of a into cos of b plus sine of a into sine of b. So these were the 4 fundamental formulas. From this we will derive the values of
tan of a plus b, tan of a minus b, and others. So tan of a plus b is equals to tan of a plus tan of b by 1 minus tan of a into tan of b. Now how this formula comes? So tan a plus b equals to sin a plus b by cos a plus b. That sin of a plus b is equals to sin of a into cos of b plus cos of a into sin of b, and cos of a plus b is equals to cos of a into cos of b minus sin of a into sin of b. Now what we will do is we will divide both the numerators and denominators by cos a cos b. So it will be like sin of a into cos of b plus cos of a into sin of b whole divided by cos a cos b, and denominator will be cos of a to cos of b minus sin of a into sin of b whole divided by cos a cos b. So sin of a into cos of b divided by cos of a into cos of b, cos b will be cancelled. Cos of a into sin of b divided by cos of a into cos of b, cos a will be cancelled. Again in the denominator, cos of a into cos of b divided by cos of a into cos of b, both will be divided and it will become 1. And sin of a into sin of b divided by cos of a into cos of b will be sin of a by cos of a is tan of a, and sin of b by cos of b is tan of b. So we will get the formula tan of a plus tan of b, tan of a plus b. Next we will see what is the value of tan of a minus b. So tan of a minus b is tan of a minus tan of b whole divided by 1 plus tan of a into tan of b. Now tan of a minus b is equals to sin of a minus b by cos of a minus b. We will derive how this formula comes. So sin of a minus b by cos of a minus b is, value of sin of a minus b is sin of a into cos of b minus cos of a into sin of b, and cos of a minus b is cos of a into cos of b plus sin of a into sin of b. Just like the previous derivation, we will divide both numerator and denominator by cos of a into cos of b, which will give sin of a into cos of b divided by cos of a into cos of b minus cos of a into sin of b divided by cos of a into cos of b whole divided by cos of a into cos of b divided by cos of a into cos of b plus sin of a into sin of b divided by cos of a into cos of b, sin of a into cos of b divided by cos of a into cos of b, cos b cancels, so we have sin of a into cos of a, which is tan of a. Again cos of a into sin of b divided by cos of a into cos of b, the cos of a gets cancelled, so we have sin of b by cos of b, which is tan of b. Again cos of a into cos of b divided by cos of a into cos of b, both the numerators and denominators get cancelled and we have got 1. Now sin of a into sin of b divided by cos of a into cos of b, we have sin of a by cos of a and sin of b by cos of b, which is tan a into tan b. So we get the formula tan of a minus tan of b divided by 1 plus tan of a into tan of b. So this was the derivation of tan of a minus b. Now let's see what will be the value of sin of a plus b into sin of a minus b. So the value of sin of a plus b into sin of a minus b is sine square A minus sine square B. Now how this formula is derived? So let's see. Sine of A plus B into sine of A minus B. So the value of sine of A plus B is sine of A into cos of B plus cos of A into sine of B, and the value of sine of A minus B is sine of A into cos of B minus cos of A into sine of B. So we get, after multiplying, sine of A into cos of B whole square minus cos of A into sine of B whole square. So we have got sine square A into cos square B minus cos square A into sine square B. So what we will do is simply convert cos square A and cos square B in terms of sine square A and sine square B respectively. So sine square A into cos square B, we can write cos square B as 1 minus sine square B. Next, minus cos square A, we can write 1 minus sine square B, and we have sine square B, so we can write, so we get sine square A minus sine square A into sine square B minus sine square B plus minus minus plus, so we get sine square A into sine square B. So plus of sine square B and minus of sine square B gets cancelled, so we have only sine square A and sine square B. Sine square A minus sine square B. So you can see the value of sine of A plus B into sine of A minus B is sine square A minus sine square B. So this was the derivation of sine of A plus B into sine of A minus B equal to sine square A minus sine square B. So now let's see what will be the value of cos of A plus B into cos of A minus B. So the value of cos of A plus B into cos of A minus B is cos square A minus sine square B. Now let's see how this formula is derived. So the cos of A plus B, we know that cos of A plus B is equal to cos of A into cos of B minus sine of A into sine of B, and cos of A minus B is equals to cos of A into cos of B plus sine of A into sine of B. Now after multiplying, we get cos of A into cos of B whole square minus sine of A into sine of B whole square. What we will get is cos square A into cos square B minus sine square A into sine square B. So what next we will do is we will convert sine square A and sine square B in terms of cos square A and cos square B respectively. So it will be like cos square A into cos square B minus, we can write sine square A in terms of 1 minus cos square A and sine square B as 1 minus cos square B. So after multiplication, what we will get is cos square A into cos square B minus 1 minus cos square A minus cos square A plus cos square A into cos square B. Okay, so what we will get is ultimately cos square A into cos square B minus 1 plus cos square A plus cos square B minus cos square A into cos square B. So minus of cos square A into minus of cos square B will be cancelled and will be left with minus 1 plus cos square A plus cos square B. So cos square A minus 1 plus cos square B, we can write cos square A minus of 1 minus cos square B. So it will be ultimately is cos square A minus 1 minus cos square B is sine square B. So the value of cos square A plus B into cos square A minus B is cos square A minus sine square B is derived in such a way. So this was the derivation of the formula. Now we will see what will be the value of sine of A plus B plus C. So the sine of A plus B plus C is equals to sine of A into cos of B into cos of C plus cos of A into sine of B into cos of C plus cos of A into cos of B into sine of C minus sine of A into sine of B into sine of C. So we will see the derivation of this formula. So what we will do is let A plus B equals to X and C equals to Y. So we will apply the formula for sine of A plus B here. So sine of X plus Y will be equal to sine of X into cos of Y plus cos of X into sine of Y. So we'll now put the values of X and Y. So what we'll do is sine of A plus B into cos of C plus cos of A plus B into sine of C. So sine of A plus B is sine of A into cos of B plus cos of A into sine of B, and this will be multiplied by cos C as a whole, and plus the value of cos of A plus B is cos of A into cos of B minus sine of A into sine of B. This will be multiplied with sine C as a whole. After multiplication we will get is cos of C into sine of A into cos of B plus cos of C into cos of A into sine of B, and cos of A into cos of B into sine of C minus sine of A into sine of B to sine of C. After arrangement we will get sine of A into cos of B into cos of C plus cos of A into sine of B into cos of C, cos of A into cos of B into sine of C minus sine of A into sine of B into sine of C. So this was the derivation of the formula sine of A plus B plus C equals to sine of A into cos of B into cos of C plus cos of A into sine of B into cos of C plus cos of A into cos of B into sine of C minus of sine of A into sine of B into sine of C. Now we will see what will be the value of cos of A plus B plus C. So the value of cos of A plus B plus C is cos of A into cos of B into cos of C minus cos of A into sine of B into sine of C minus sine of A into cos of B into sine of C minus sine of A into sine of B into cos of C. So we'll see how this formula is derived. For this we'll simply assume A plus B equals to X and C equals to Y. So we have got here is cos of X plus Y. So we'll simply use the formula of cos of A plus B. So for that, cos of X plus Y is equals to cos of X into cos of Y minus sine of X into sine of Y. Now let's put the formula for cos of X and Y. So the value of cos of X was cos of A plus B and cos of Y was cos of C, and sine of X was sine of A plus B and Y was sine of C. So we'll put the formula for cos of A plus B, which is cos of A into cos of B minus sine of A into sine of B whole multiplied into cos of C, and minus of sine of A plus B is sine of A into cos of B plus cos of A into sine of B, and this will be multiplied into sine of C. Now after multiplication what we'll get is cos of A into cos of B into cos of C minus cos of C into sine of A into sine of B, and then minus sine of A into sine of B into cos of C, and minus cos of A into sine of B into sine of C. So this was the derivation of the formula cos of A plus B plus C equals to cos of A into cos of B into cos of C minus cos of A into sine of B into sine of C minus sine of A into cos of B into sine of C minus sine of A into sine of B into cos of C. Now let's see what will be the value of tan of A plus B plus C. So the value of tan of A plus B plus C is tan of A plus tan of B plus tan of C minus tan of A into tan of B into tan of C whole divided by 1 minus tan of A into tan of B minus tan of B into tan of C minus tan of C into tan of A. Now let's see how we can derive this formula. So we will simply take a plus b equals to x and c equals to y. So we have got here is tan of x plus y. So we will simply put the value of formula for tan of a plus b, which is equals to tan of x plus tan of y by 1 minus tan of x into tan of y. Now we'll put the values for x and y, which is equals to tan of a plus b plus tan of c. In the denominator 1 minus tan of a plus b into tan of c. So tan of a plus b is again tan of a plus tan of b by 1 minus tan of a into tan of b plus, and this will be plus tan of c, and in denominator same 1 minus tan of a plus tan of b by 1 minus tan of a into tan of b, and this will be multiplied with tan of c. So after multiplication and simplification, we will simply get is tan of a plus tan of b plus tan of c minus tan of a into tan of b into tan of c, and this will be divided by 1 minus.
Drop the clutch, pedal to the floor, turn that gate.
Now let's talk about some rare condition, which are if a plus b equals to pi, then sine of a equals to sine of b, and cos of a equals to minus cos of b, and tan of a equals to minus tan of b. Again, if a plus b equals to 2 pi, then sine of a equals to minus sine of b, cos of a equals to cos of b, and tan of a equal to. Now let's see what will be the values of trigonometric ratios at multiples and submultiples of various angles. So first of all, we will see the values of trigonometric ratios at the angles which are multiples of 2. So let's see. So our first value is sine of 2x. So sine of 2x is equal to 2 sine x into cos x. Now how this formula is derived? So sine of 2x we can write sine of x plus x. So we will apply the formula of sine of a plus b, which is equals to sine of a into cos of b plus cos of a into sine of b. So sine of x into cos of sine of x plus x is equals to sine of x into cos of x plus cos of x into sine of x. So which will be equal to 2 sine of x into cos of x. So this is the derivation of the formula sine of 2x equals to 2 sine x into cos x. Next is our cos of 2x. So cos of 2x is equals to cos square x minus sine square x. Let's derive the formula first. So cos of 2x is equals to cos square x minus sine square x. Now how this formula is derived? Cos of 2x we can write cos of x plus x, where a is equals to x and b is equals to x. So we can apply the formula of cos of a plus b, which will be equals to cos of x into cos of a into cos of b minus sine of a into sine of b. So as a and b both are x, so it will be cos x only. So cos of x into cos of x is cos square x, and sine of x into sine of x is sine square x. So the value is derived cos square x minus sine square x. So this was the derivation of the formula cos of 2x equals to cos square x minus sine square x. Cos of 2x is equals to 2 cos square x minus 1 and 1 plus cos 2x equals to 2 cos square x. So as told earlier that cos of 2x is equals to cos square x minus sine square x. So we can write sine square x in terms of cos square. So cos of 2x will be equals to cos square x, and sine square x is 1 minus cos square x. So after breaking cos square x minus 1, and this will be minus minus plus cos square x, which will be equals to 2 cos square x minus 1. So this was the derivation. Next is our 1 plus cos 2x is equals to cos square x. This is simple, as we have derived here that cos of 2x is equals to 2 cos square x minus 1. So what we will do is simply take the minus 1 to this side, and it will become like 1 plus cos of 2x is equals to 2 cos square x. So this was the derivation of the two formulas. Cos of 2x equals to 2 cos square x minus 1, and 1 plus cos 2x equals to 2 cos square x. Now we will see how we can express the values of cos of 2x in terms of sin x. So the value of cos of 2x is equals to 1 minus 2 sin square x, and 1 minus cos of 2x is equals to 2 sin square x. Now how this formula is derived, let's see. Cos of 2x is equals to cos square x minus sin square x. So we will convert cos square x in terms of sin square x. So cos of 2x is equals to, we can write cos square x as 1 minus sin square x and minus sin square x. So it will be like 1 minus sin square x and again minus sin square x. So it will be 1 minus 2 sin square x, and 1 minus 2 sin square x was it, and now it was 1 minus cos 2x equals to 2 sin square x. So cos of 2x is equals 1 minus 2 sin square x. So what we will do is take the 2 sin square x to this side and bring cos of 2x to this side. So it will be 2 sin square x will be equals to 1 minus cos of 2x. So this was it. This was the derivation of the formula. Cos of 2x is equals to 1 minus 2 sin square x, and 1 minus cos of 2x equals to 2 sin square x. Now let's see what will be the value of tan of 2x. So the value of tan of 2x is equals to 2 tan x by 1 minus tan square x. Now how this formula is derived. Tan of 2x we can write tan of x plus x, and now we'll apply the formula for tan of a plus b. Here a and b both are x, so what we will do is tan of a plus b is tan of a plus tan of b by 1 minus tan of a into tan of b. So tan of x plus x will be tan of x plus tan of x whole divided by 1 minus tan of x into tan of x, and this will be equals to 2 tan x in the numerator and whole divided by 1 minus tan square x. So this was the derivation of the formula tan 2x equals to 2 tan x whole divided by 1 minus tan square x. Now we will see what will be the value of sin 2x in terms of tan x. So the value of sin 2x in terms of tan x is 2 tan x by 1 plus tan square x. Now let's see how this happens. So sin of 2x we can write is, derive this 2 tan x by 1 plus tan square x we can write as 2 sin x by cos x and 1 plus sin square x by cos square x. So after simplification, 2 sin x by cos x, and this will be sin square x plus cos square x by cos square x. So cos square x and cos x cancels. Sin square x plus cos square x is equals to 1, and this goes here and cos x goes here, and it will be equal to 2 sin x into cos x, and so the formula is derived, which is equals to sin of 2x. So in this case, the proving of this formula was simpler in case of proving the RHS and bringing it to form of LHS. So this was the derivation of the formula sin of 2x in terms of tan x, that is sin of 2x equals to 2 tan x whole divided by 1 plus tan square x. Now let's see what will be the value of cos of 2x in terms of tan x. So the value of cos of 2x in terms of tan x is 1 minus tan square x by 1 plus tan square x. So how we will derive this formula? So what we will do is we will write tan square x, tan x in terms of sin x and cos x, that will be equals to 1 minus sin square x by cos square x and 1 plus sin square x by cos square x. So So after simplification, what we'll get is cos square x minus sin square x by cos square x in the numerator, and in the denominator what we'll get is cos square x plus sin square x whole divided by cos square x. So cos square x and cos square x gets cancelled, and what will left with is cos square x minus sin square x by cos square x plus sin square x. So cos square x plus sin square x is equals to 1, and so this will be cos square x minus sin square x. So cos square x plus sin square x is equals to 1, so this will be cos square x minus sin square x whole divided by 1, and cos square x minus sin square x is equals to cos of 2x. So this was the derivation. So this was the derivation of the formula cos 2x equals to 1 minus tan square x by 1 plus tan square x. Now let's take a look at the values of different trigonometric ratios at angles which are multiples of 3. First is the value of sine of 3x. So the value of sine of 3x is equals to 3 sine x minus 4 sine cube x. Now let's see how this formula is derived. So sine of 3x we can write sine of 2x plus x. So we'll apply the formula for sine of a plus b, that is sine of 2x into cos of x plus cos of 2x into sine of x. Now sine of 2x will be 2 sine x cos x and again multiplied into cos x, plus cos of 2x will be cos square x minus sine square x, and this will be multiplied with sine x again. So first we'll get 2 sine x cos square x, and then again we'll get sine x cos square x minus sine cube x. So what we'll get is 3 sine x cos square x and minus sine cube x. Now we'll convert cos square x in terms of sine x. So 3 sine x and cos square x we can write 1 minus sine square x minus sine cube x again. So what we'll get is 3 sine x minus again sin x into sin square x, 3 sin cube x and minus sin cube x. So we will get finally 3 sin x minus 3 sin cube x and minus sin cube x. So it will become 4 sin cube x. So ultimately 3 sin x minus 4 sin cube x. So this was the derivation of the formula sin of 3x equals to 3 sin x minus 4 sin cube x. Now let's take a look at the value of cos of 3x. So cos of 3x is equals to 4 cos cube x minus 3 cos x. So now let's see how this formula is derived. So cos 3x we can write cos of 2x plus x. Now we'll apply the formula for cos of a plus b, which will be equals to cos of 2x into cos of x minus sine of 2x into sine of x. Now we'll simplify it. So cos of 2x is cos square x minus sine square x into cos of x, and minus sine of 2x is 2 sine x into cos x, and it will be multiplied with sine x again. So after simplification we'll get cos cube x minus sine square x into cos x, and then again minus 2 sine square x into cos x minus sine square x into cos x and minus 2 sine square x into cos x. So we'll get cos square x minus 3 sine square x cos x, cos cube x is here, and we'll convert sine square x in terms of cos x. So this will be, you can write sine square x as 1 minus cos square x, and this will be multiplied whole into cos x. So cos cube x minus 3, after simplification we will get cos of x plus cos cube x, because minus minus becomes plus. So we'll get 3 cos cube x plus 3 cos cube x, we'll get 4 cos cube x minus 3 cos x. This was it. So this was the derivation of the formula cos of 3x equals to 4 cos cube x minus 3 cos x. Now let's see what will be the value of tan of 3x. So the value of tan of 3x is 3 tan x minus tan cube x whole divided by 1 minus 3 tan square x. So now let's see how this formula is derived. So tan of 3x we can write tan of 2x plus x. Now we'll apply the formula for tan of a plus b, that is tan of 2x plus tan of x by 1 minus tan of 2x into tan of x. Now let's simplify it. That will be 2 tan of 2x is 2 tan x by 1 minus tan square x and plus tan x, and in the denominator 1 minus 2 tan x will be 2 tan x by 1 minus tan square x into tan x. Now we will further simplify it. This will be 2 tan x into plus taking LCM, tan x into 1 minus tan square x, that will be tan x minus tan cube x and all divided by 1 minus tan square x, and in the denominator it will be 1 minus tan square x minus 2 tan square x all divided by 1 minus tan square x. In the numerator and denominator both are divided by 1 minus tan square x, so 1 minus tan square x gets cancelled and we will be left with 2 tan x plus tan x minus tan cube x whole divided by 1 minus tan square x minus 2 tan square x. So after simplification we will get is 2 tan x plus tan x is 3 tan x and minus tan cube x, and in the denominator 1 minus tan square x minus 2 tan square x, it will be minus 3 tan square x. So our formula is derived 3 tan x minus tan cube x whole divided by 1 minus 3 tan square x. So this was the derivation of the formula tan of 3x is equals to 3 tan x minus tan cube x whole divided by 1 minus 3 tan square x. Now let's talk about the values of trigonometric ratios at angles which are submultiples of 2. So our first value will be sine of x by 2. So the value of sine of x by 2 is root under 1 minus cos x whole divided by 2. So let's see how this formula is derived. So root under 1 minus cos x by 2, we can write root under 1 minus cos of 2 into x by 2 whole divided by 2, and then what we'll do is simply convert the cos of 2 into x by 2 in terms of, we'll break it, and what we'll get is 1 minus cos square x by 2 minus sine square x by 2. This will be divided by 2. So 1 minus cos square x by 2 we can write sine square x by 2, and this was plus because cos of 2x is equals to cos square x minus sine square x. So and minus minus becomes plus, and then sine square x by 2, this will be whole divided by 2 and root under. So we'll get is sine square x by 2 plus sine square x by 2, it is 2 sine square x by 2, and in the denominator it is 2. So in the denominator and numerator there are 2, these will get cancelled, and what we'll get is root under sine square x by 2. So this sine square x gets cancelled because there is root, and we'll get sine of x by 2. So this was the derivation of the formula sine of x by 2 is equals to root under 1 minus cos x by 2. Now let's take a look at the value of cos of x by 2. So the value of cos of x by 2 is square root of 1 plus cos x by 2. So let's see how this formula is derived. So root under 1 plus cos x, we can write 1 plus cos of 2 into x by 2 and whole divided by 2 root under. This will be further derived, and cos of 2x, cos square x minus sine square x, this will be equals to 1 plus cos square x by 2 minus sine square x by 2 and whole divided by 2. So we'll simply arrange it, 1 minus sine square x by 2 plus cos square x by 2 and whole divided by 2. So 1 minus sine square x by 2 we can write cos square x by 2 and plus cos square x by 2 whole divided by 2 root under. So cos square x by 2 plus cos square x by 2 is equals to 2 cos square x by 2 and whole divided by 2 root under. So in the numerator there is 2 and the denominator there is 2. So 2 gets cancelled and it will be root under cos square x by 2. So it becomes cos of x by 2. So this was the derivation of the formula cos of x by 2 is equals to root under 1 plus cos x whole divided by 2. Now let's take a look at the value of tan of x by 2. So the value of tan of x by 2 is equals to root under 1 minus cos x by 1 plus cos x. So it is very simple. For tan of x by 2 equals to root under 1 minus cos x by 1 plus cos x is very simple to derive. So tan of x by 2 we can write sine of x by 2 by cos of x by 2. The value of sine of x by 2 was root under 1 minus cos x by 2, and value of cos of x by 2 was root under 1 plus cos x whole divided by 2. So we'll get is root under 1 minus cos x by 2 divided by root under 1 plus cos x by root 2. Here will be root 2. So root 2 gets cancelled, and we will get root under 1 minus cos x by root under 1 plus cos x, which can be written as root under 1 minus cos x by 1 plus cos x. So this was the derivation of the formula tan of x by 2 is equals to root under 1 minus cos x. Let's look at some rare conditions. First is the value of cos of x into cos of 2x into cos of 2 to the power 2x into cos of 2 cube x. Series will continue till cos of 2 to the power n minus 1 into x. The value of this equation is sine of 2 to the power nx by 2 to the power n into sine x. Next is the value of sine x into sine of pi by 3 minus x into sine of pi by 3 plus x. The value of this equation is 1 by 4 into sine of 3x. Next is cos of x into cos of pi by 3 minus x into cos of pi by 3 plus x is 1 by 4 into cos of 3x. So these were the three rare conditions. Now let's take a look at the values of trigonometric ratios at some rare values of angles. So first is value of sine of pi by 10. So the value of sine of pi by 10 is root under 5 minus 1 whole divided by 4. The value of cos of pi by 10 is root under 10 plus 2 root 5 whole divided by 4. Next, the value of cos of pi by 5. So the value of cos of pi by 5 is root under 5 plus 1 whole divided by 4. And next and lastly, sine of pi by 5. So the value of sine of pi by 5 is 10 minus 2 root 5 whole divided by 4.
Pistons pumping, all 800 horses running. Oh baby, 125 in the middle of the night, got my engine thundering. Dream machine, racing queen, I'll take you wherever you wanna go. Let's blow this down, break the speed of sound. Tonight we all know racing. Dream machine, racing queen, you make my heart beat, you make my heart beat. Dream machine, racing queen.
Now let's take a look at the transformation of some trigonometric equation to simpler forms. So first equation is 2 sine A into cos B. So the value of 2 sine A cos B is sine of A plus B into sine of A minus B. So let's see how this formula is derived. So sine of A plus B plus sine of A minus B, we can write sine of A into cos of B plus cos of A into sine of B plus sine of A minus B, we can write sine of A into cos of B minus cos of A into sine of B. So sine of A into cos of B plus sine of A into cos of B, we get 2 sine of A into cos of B, and plus cos of A into sine of B minus cos of A into sine of B gets cancelled. So we get 2 sine of A into cos of B. So this was the derivation of the formula 2 sine A cos B equals to sine of A plus B plus sine of A minus B. Our next equation is 2 cos A cos B. So the value of this trigonometric equation 2 cos A cos B is cos of A plus B plus cos of A minus B. So let's see how this formula is derived. So cos of A plus B, we can write cos of A into cos of B minus sine of A into sine of B plus cos of A minus B, we can write cos of A into cos of B plus sine of A into sine of B. So plus sine of A into sine of B minus sine of A into sine of B gets cancelled. So we are left with cos of A into cos of B plus cos of A into cos of B. So cos of A into cos of B plus cos of A into cos of B is 2 cos of A into cos of B. So our formula is derived to cos of A into cos of B. So this was the derivation of the formula 2 cos of A into cos of B equals to cos of A plus B plus cos of A minus B. Next trigonometric equation is our 2 cos of A into sine of B. So the value of 2 cos of A into sine of B is sine of A plus B minus sine of A minus B. Sine of A plus B minus sine of A minus B. Now let's see how this formula is derived. So sine of A plus B we can write sine of A into cos of B plus cos of A into sine of B minus sine of A minus B we can write sine of A into cos of B minus minus becomes plus, so it will be plus cos of A into sine of B. So sine of A into cos of B and minus sine of A into cos of B gets cancelled and we are left with cos of A into sine of B plus cos of A into sine of B. That is equals to 2 cos of A into sine of B. So this was the derivation of the formula or the equation 2 cos of A into sine of B is equals to sine of A plus B minus sine of A minus B. Our next trigonometric equation is 2 sine of A into sine of B. So the value of 2 sine of A into sine of B is cos of A minus B minus cos of A plus B. Now let's see how this formula is derived. So cos of A minus B we can write cos of A into cos of B plus sine of A into sine of B, and minus cos of A plus B we can write cos of A into cos of B minus sine of A into sine of B, and this minus becomes minus minus plus, so minus cos of A into cos of B plus cos of A into cos of B gets cancelled and we are left with sine of A into sine of B plus sine of A into sine of B. So the sine of A into sine of B plus sine of A into sine of B becomes 2 sine of A into sine of B, which is our RHS. So this was the derivation of the formula 2 sine of A into sine of B is equals to cos of A minus B minus cos of A plus B. Next, let's take a look at the value of the equation sine of C plus sine of D. So the value of the equation sine of C plus sine of D is 2 sine C plus D by 2 into cos C minus D by 2. So let's see how this formula is derived. So we'll rub it because the derivation is a bit long. 2 sine C plus D by 2 and cos C minus D by 2. So what we'll do is, first of all, let's assume C plus D as X and C minus D as Y. So this will be 2 sine X by 2 and cos Y by 2. Value of sine of X by 2 is 2 root under 1 minus cos X by 2 whole divided by 2, and value of cos of Y by 2 is 1 plus cos Y by 2, cos Y whole divided by 2. That will be root 2 and 2 gets cancelled, so we'll be left with is root under 1 minus cos X into 1 plus cos X. So this will be 1 minus cos X, 1 minus cos X plus cos X minus cos X cos Y. So we'll be left with root under 1 minus cos X into 1 plus cos Y. So after simplification, we'll simply get root under 1 minus cos X plus cos Y minus cos X cos Y. Now let's put the values of X and Y. So we'll get root under 1 minus cos of A plus B plus cos of A minus B minus cos of A plus B into cos of A minus B. So this will be further simplified and we'll break cos of A plus B as 1 minus cos of A into cos of B, minus minus becomes plus, and we'll get sine of A into sine of B plus, and cos of A minus B is cos of A into cos of B plus sine of A into sine of B, and minus cos of A into cos of B minus sine of A into sine of B into cos of A into cos of B plus sine of A into sine of B. So further we'll get root under 1 minus cos A cos B plus sine A sine B plus cos A cos B. So minus cos A cos B and plus cos A cos B gets cancelled. So we are left with 1
plus 2 sin A sin B, and then minus cos square A into cos square B minus sin square A into sin square B. Simply applied A plus B into A minus B, that is A square minus B. So we'll get again root under 1 plus 2 sin A sin B minus 1 minus into cos square A, we will write 1 minus sin square A, and cos square B we can write 1 minus sin square B. Minus minus becomes plus, so we'll get plus sin square A into sin square B. So what we'll next will do is simply simplify it. So we'll get 1 plus 2 sin A sin B minus of 1 minus sin square B minus sin square A plus sin square A sin square B, and plus sin square A into sin square B. So we'll again simplify it, and we'll get root under 1 plus 2 sin A sin B, 2 sin A sin B minus 1 minus minus plus sin square B minus minus plus sin square A, and plus becomes minus minus sin square A sin square B, and plus sin square A sin square B gets cancelled. So what we are left with is, we are left with root under and 1 and minus 1 gets cancelled. So we are left with root under sin square A plus sin square B plus 2 sin A sin B. So this will be root under sin A plus sin B whole square. So sin A sin B whole square, root under sin A sin B whole square will be sin A plus sin B. So this was the derivation of the formula sin C plus sin D equals to 2 sin C plus D by 2 into cos C minus D by 2. Rest all other derivations will be same, as these derivations are so long, so I am not showing the another ones. The next equation is sin C minus sin D. Sin C minus sin D is equals to 2 sin C minus D by 2 into cos C plus D by 2. Next, value of cos of C plus cos of D, which is 2 cos C plus D by 2 into cos C minus D by 2. And next we are getting value of cos of C minus cos of D, which is equals to minus 2 sin C plus D by 2 into sin of C minus D by 2. So these were all about the transformations of some trigonometric equation into their simpler forms.
Engine with a fuel injection. Drop the clutch, pedal to the floor. Turn that giddy button to a lion's roar. Dream machine, racing queen.
Now let's talk about general solution for some values of trigonometric ratios. First, an equation containing trigonometric function of unknown angles is known as a trigonometric equation. So this was the definition for trigonometric equation. Next is, a solution of trigonometric equation is the value of the unknown angles that satisfies the equation. So is the definition for the solution of trigonometric ratios. Now let's take a look at the general solution of the trigonometric ratios in standard form. These are, if sine of theta equals to 0, then theta equals to n pi, where n is a whole number. Next is, if cos of theta equals to 0, then theta equals to 2n plus 1 into pi by 2, where n is a whole number. Next, tan theta equals to 0, then theta equals to n pi, where n is a whole number. Next, if sin theta equals to sin alpha, then theta equals to n pi plus minus 1 whole to the power n alpha, where n belongs to z or a real number. Cos theta equals to cos alpha, then theta equals to n pi plus minus alpha, where n is a whole and a real number. If tan theta equals to tan alpha, then theta equals to n pi plus alpha, where n is a real number. And lastly, if sin square theta equals to sin square alpha, cos square theta equals to cos square alpha, and tan square theta equals to tan square alpha, then theta equals to n pi plus minus alpha, where n belongs to z or a real number. Last note is, the equation A cos theta plus B sin theta equals to C is solvable for mod of C less than equals to root under A square plus B square. So this was all about the general solution for some values of trigonometric ratios.
this was all about the important formulas of trigonometry. So this was all for today. We'll meet in the next video. Till then, stay connected and like the video, share the video and comment on the video and subscribe to our channel. And do check the link in the description for the PDF notes. Thank you. Jai Hind.